Hello, good morning, everyone. We'll start the webinar. So today's webinar is a stakeholders webinar organized by the LIFE-FLAREX project as the project final event. First of all, I would like to thank you all for joining this webinar in this strange situation. So first of all, I will introduce a little bit about our organization. So AI Textiles is the project coordinator of the LIFE-FLAREX project. It's a Catalan technical textile cluster. It has been around since 2008, and it brings together the different innovative companies around technical textile value chain. As part of the AI Textiles strategic projects, we have 4 main areas of operation. We have cluster excellence to improve our services to our members, internationalization services to help them go international. We have also emerging industries as part of innovation for the companies, and on the core we have analysis and knowledge structure with key projects like the LIFE-FLAREX project that it's here today for sustainability, and also context network. The cluster has led 2 main projects on focused towards sustainability, the LIFE-FLAREX project and the MIDWOR-LIFE project. For today webinar, we will have first presentations from different policy aspects, including the EU Green Deal, the LIFE program, the industry view on substitution for the textile sector, a presentation from ECHA about the PFAS-a state, and the ChemSec Tools for substitution. We will have a presentation about the key results of the LIFE-FLAREX project, and then we will have invited projects to share their results, particularly MIDWOR-LIFE and AskREACH. We will have a Q&A at the end of the session of about 20-25 minutes. Meanwhile, if in case you have any question, you can also use the platform to write the question. So I would appreciate if you can write the questions anytime. We will, if they are just a clarification, it will be solved by chat. Otherwise, if it's more debateful, we will open it up during the Q&A session at the end of the webinar. So here you have the instruction. You have to click the red arrow if you have it minimized, and then you will have a question section that you can directly type the questions you have. Once you have the question answer, you will have it in green, so you will see it in here. So thank you a lot, and now we are going to start with the first presentation from Katarina. I will give you the floor and for presenting. Hello, Katarina.
Yes, hello, good morning, everyone. I will try to share my screen with you.
Yes.
Just give me a moment.
Yes. Okay, great.
Is it possible to?
Yes.
See? So good morning once again. My name is Katarina Pirshelova. I'm working in DG Environment, European Commission, in the Sustainable Chemicals Unit. And it's my pleasure to take you today through an update about the current thinking and initiatives that are in preparation in the European Commission. And I think it's the right time to talk about this, because it is maybe the best moment to put all inputs together before the Commission would come with its next deliverables and initiatives. As you all know, in the beginning of this Commission term, the Commission already early announced its ambition to do and think differently, and it has adopted the EU Green Deal an initiative and tool that sets up a strategy with an objective to transform the EU economy for future in a sustainable way. Big part of this, of course, it has many aspects, but a big part of this, as our life as well, lives linked to what is surrounding us and chemicals and pollution. So one part of the ambition was to strive for zero pollution, for a toxic-free environment. And within this, of course, there are aspects of legislative action, of research, innovation, and move in thinking. And also materializing this zero pollution ambition should lead to toxic-free environment. That to arrive at toxic-free environment, we need actions to prevent pollution, not only measures to clean and remedy it. So this is a shift in thinking. What also is embedded in the European Green Deal is that we need to better monitor, better report, prevent, remedy pollution, and that from all media that are surrounding us, be it air, water, soil, and of course for human health, consumer products and everything we are encircled. Therefore, Commission in the European Green Deal committed to propose measures to address pollution, not only that is already there, but also think about how to address new sources of pollution or particularly harmful sources of pollution. You may all be aware that there are recently such issues like microplastic, plastic pollution in general, and a lot of chemicals pollution. So the European Green Deal also brought a commitment from the Commission to present a chemical strategy for sustainability with obvious goals to protect citizens and the environment, to protect it even better than we are doing already now, and to pave it in a sustainable way, encouraging innovation for safe and sustainable alternatives to chemicals that we are using or need to use. So you see, this is a direct link to substitution. That is the main topic of the event today. Substitution of hazardous chemicals is also at core of the current European Commission thinking. The idea in the strategy should be to find and reflect how we can better combine health and environmental protection. And of course, we are living in the EU that is already a front runner in this field, and we would like also to think how all these efforts in a sustainable way can increase globally competitiveness of the European Union. What are the main ideas linked to this is, of course, we have certain legal framework currently, and we work within it, but we need to find ways to simplifying and strengthening it, so it's not on the detriment of the level of protection of the health and the environment. We are coming into a new era where we may need to find also new strategies how we are dealing with chemicals. So to rationalize, the idea is also to move to so-called one substance, one assessment approach. And of course, because there is new and rapidly evolving world around us, we want to more rapidly react and to be able to more rapidly react and reflect new scientific evidence and risk posed by now certain specific groups of chemicals like endocrine disruptors, hazardous chemicals in products, combination effect of different chemicals, and last but not least, also reflect how we can address very persistent chemicals that already by the fact that they are very persistent and lasting for decades or even centuries, once they are out and polluting, create a particular concern. Of course, the strategy that we are thinking about needs to link to other priorities and initiatives that the Commission and also DG Environment is currently putting in place. And you can see, to mention just schematically, it really is linked to circular economy, farm to fork initiatives, biodiversity, zero pollution, farm to fork. It all fits into the cancer action plan that this commission has also reinitiated. We are all, of course, living in digital world, so we need to also consider digital tools. And last but not least, in the current COVID-19 situation, this strategy is also becoming important to promote health and prevention, not only in the EU, but also beyond its frontiers. And we should also not forget that this strategy can offer also tools to boost economic recovery after this crisis. The commitment in the European Green Deal to come with a chemical strategy for sustainability came after more than 20 years. The last strategic paper on chemicals has been published in 1999, the white paper on chemicals. Back in time, this strategic white paper gave birth to the world maybe strongest chemicals legislation, REACH. Now some media already start talking that this strategy is expected to be yet another game changer. So this is where a lot is expected, we feel, from the strategy. The development of this strategy has already started, and it's in internal preparation. You may have noticed that there is already a public consultation on the strategy's roadmap ongoing. I think it's closing this week on the 20th of June. So you could still, if any ideas, you could still provide your input. The aim is to adopt the strategy sometimes in the autumn. We are targeting September, and then from next year on, there would be a period for coming with follow-up proposals stemming from strategy, and of course for strategy implementation. The idea is, of course, to address all the main areas I was talking about, like accompany the strategy with more detailed Commission staff working document with analysis for different particular issues, For example, one part should be addressing combination effect of chemicals, certain obligations that were supposed to be revisited from the REACH regulation. It should also be accompanied by the fitness check on endocrine disruptors. There should be actions analyzed and proposed on very persistent chemicals like perfluoroalkyl chemicals, PFAS, and so on and so forth.
1 minute.
Yes. So just to coming back to what is linking all this to today's event is, as I said, substitution of hazardous chemicals is strongly linked to striving for sustainability. We wish for a shift to substances, materials, and products that already are safe and sustainable by design. In this crisis time, of course, there is also an interest in boosting research and innovation and promoting strategic autonomy of the European Union for chemicals that are essential for society, like talking about different antiviral treatments or disinfectants and so on. At the same time, we strive for stronger environmental protection from hazardous chemicals and addressing those that are most persistent and forever chemicals like PFAS. I have noticed that part of this event is also dedicated to PFAS. So I just wanted to briefly present the initiatives of DG Environment that have been initiated already some time ago, and the impulses that are coming also from member states on this group of chemicals. Already last year in the European Council in June and in December, member states were calling on the Commission for an action plan on how to deal with these very persistent chemicals, PFAS, and on actually eliminating all non-essential uses of these chemicals because of the concern they are bringing. This is a very big group of chemicals, and regulating them one by one would take us a very, very long time. So actually, these member states are calling for a change in a mindset and for an action to look at all these big group chemicals together as a group and regulating it as a group and using in this action plan all available regulatory and non-regulatory instruments. Later last year, Netherlands and then now the group of member states already increased. The Netherlands announced the intention to take restriction action on all PFAS substances under REACH to ban all their uses except of essential uses. This preparatory work for this is already starting, and our colleague from the European Chemicals Agency will provide us more information later today about where they stand. From the Commission perspective, DG Environment has already started its activities on this group of substances for somehow 2 years ago, and initiated 2 studies on all PFAS substances, their uses in firefighting foams and in textile, upholstery, leather, apparel, and carpets, and trying to find out data on their particular uses and their alternatives in these areas. This was a process with involvement of stakeholders and targeted consultations to gather information for further regulatory activities. and it should fit in this current initiative to prepare REACH restrictions and also provide information for further international activities on these substances, for example, under the persistent organic pollutants initiatives internationally. These reports are now to be finalized. The report on firefighting foams has been just yesterday published on the website of the European Chemicals Agency, and the report on textiles should be coming out soon during the summer or by the end of this summer. So as you see, there is a lot ongoing, and events like this are very welcome because they provide already an insight on particular issues that are of the Commission interest. And I would only encourage you to follow up these developments from the policy side, because that can further help steering also your particular substitution activities on hazardous chemicals. Thank you very much. If you have any questions, please either post them by chat or then keep them for the Q&A session. Thank you.
Thank you very much, Katarina. Just a minor comment on the logistics. We will be sharing the presentations and the recording of the session in the coming days. So, because I see some questions, so I wanted to give everyone the heads up that we will be sharing the presentations and the video. Now, our next speaker will be Manuel Montero from EASME to present the LIFE program and the funding opportunities from the LIFE program, like the project that we are talking today. The LIFE-FLAREX is one of these. So, Manuel, the floor is yours.
Hello, good morning to everyone. I'm gonna try to put the presentation. Do you see now the?
We see just the PowerPoint, not the full screen. Now.
You see now?
Yes. Thanks.
Okay. Hello, good morning to everyone. I'm gonna present today the LIFE some aspect of the LIFE program in relation to the topic of chemicals. So I work for EASME. EASME is the executive agency of small and medium-sized enterprises, and the main objective of the agency is to implement programs on behalf of the European Commission. And I work for the LIFE unit, and we are implementing the LIFE program. So the overall objective of the LIFE program is to contribute to the implementation, update, and development of the EU environmental and climate policy and legislation. So this is the main objective of the program. So more specific objective is the program aiming at contributing towards a resource efficient, low carbon, and climate resilient economy, protecting and improving the environment, maintaining and improving biodiversity, ecosystems, and in particular the Natura 2000 network, improving the development, implementation, and enforcement of Union environmental and climate policy and legislation, integrating and mainstreaming of environmental and climate objectives into other Union policies, improving environmental and climate governance, and the implementation of the 7th Environmental Action Program. So This is a little summary of the program. As you can see in the box, the one in the middle, the LIFE program have a total budget of 3.4 billion for the programming period 2014-2020. The Commission has proposed an increase to 5.45 billion euro for the period 2021 from 21-27 that is currently under negotiation within the frame of the upcoming budget for the EU. So it seems that the program will continue in the future. The programs and the chemicals. So under the LIFE regulation Annex 3 and 3D, specify the thematic priority for environment and health, including chemical and noise. So this is the main thematic priority covering chemicals under the LIFE regulation. So the aim of this thematic priority is to support activity for the implementation of the specific objective for environment and health set out in the 7th Environmental Action Program, and in particular, as you can see under entry, the first entry is basically covering the REACH regulation, the biocidal product regulation, in order to ensure a safer, more sustainable or economical use of chemical, including nanomaterial. The second entry refers to noise directive because this thematic priority is covering chemicals and noise. And then the last entry is refers to the Seveso 3 directive. So as you can see, the thematic priority is covering mainly the whole EU legislation on chemicals. There is a specific topic on chemicals in the LIFE regulation, and this topic is as follows. So the objective is the reduction of the impact on the environment or human health of at least one of the following. So substances identified as hazardous to human health or to the environment under the CLP regulation. Combination effects of chemical, including endocrine disruptor, nanomaterial, biocide product, and or pesticide. As you can see, we have here almost all the family or type of substances as mentioned by my colleague Katerina. So this shall be reached through one or the more of the following: safer or more sustainable use of the substances in question, minimization of exposure to toxic chemical in product or in the environment, and the substitution with safer substances or non-chemical solution. So this is the only topic we have in chemical, but as you can see, is quite broad. So I do believe that whatever type of project idea you have in mind covering chemicals, it will suit the topic. Then there are other thematic priorities covering other subjects that are also interlinked indirectly with the chemicals. So for example, the thematic priority for water, we have, for example, this entry that is the reduction of pressure from chemical pollutant in water environment by reducing emission of priority substances and other chemicals identified as river basin specific pollutant absorbed through the use of appropriate substitutes or alternative technology, application of technology for urban wastewater treatment system to diminish or eliminate discharges of emerging pollutant as part of wastewater treatment effluents. We have also the thematic priority for waste that there is an entry clearly related to hazardous chemical, and this one is related to the identification and separation of hazardous substances containing waste to enable value-added recycling of the treated waste and safe disposal of hazardous substances. A thematic priority for soil, where we have as well a topic covering the remediation action focuses on contaminated soil. And then we have the a priority area for governance and information type of projects. And though this this priority area is aiming at raising awareness on environmental problems, EU environmental policies, tools, and all legislation among the relevant target audience and the safe use of chemicals. Since the program was published, or when the program started in the early 90s, more than 100 projects covering chemical have been funded by the LIFE program. Currently, we have 50 projects in the phase of implementation. And these projects are covering different type of them and topics. Here we have some examples. For example, we have projects that they are aiming at the development and demonstration of novel technology that result in the reduction of hazardous chemical use in different industrial processes and in agriculture, the assessment of the safety of alternative chemicals, the development of data management tool that facilitate the identification of substitute chemicals, project covering the development and demonstration of technology for groundwater and soil remediation, the development and demonstration of technology for the recovery of hazardous substances and or non-toxic alternative from wastewater and other industrial waste, the development of tools for establishing links between the presence of chemical in article and associated human impacts, increasing awareness of sustainable and safe use of chemicals. In this slide, I showed you the link to the project database, where you will find all the projects funded by the program, and of course, you will find all the projects dealing with directly or indirectly with chemicals. Just some example of project that you can have an idea what type of project we are speaking about. For example, if we speak about substitution of chemical, we have the project that is hosting this event, LIFE-FLAREX, aiming at the mitigation of environmental impacts caused by flame retardant textile finishing chemical. We have another project, another example is LIFE-FLAREX, it's Baltic pilot cases on reduction of emissions by substitution of hazardous chemical and resource efficiency being implemented in the Baltic states. We have projects that we can classify as eco-innovation for reduced production of and use of hazardous chemical. And an example is the LIFE Wait for Green, is aiming at the development of biopesticide using agro waste. Therefore, to try to substitute a standard pesticide. We have another interesting project called LIFE Trial Kill. It's an innovative and sustainable continuous process for the development of high quality trimethyl phosphate. And in this, they have a really nice prototype, and they have reached the production of trimethyl phosphate, reducing dramatically the hazardous waste in the industrial process. We have projects dealing with monitoring and assessment of the impact of chemical in the environment, and these are two of examples. This LIFE Nano Explore, working on nanomaterial in working places in urban area. We have another interesting project, LIFE Milch, and this is also dealing with the endocrine disruptant chemical and establishing what is the effects on the human health through the milk of the feeding babies. And we have projects that we call that are under the tools like awareness raising, management of chemical, hazard assessment, and exposure model. LIFE-FLAREX, for example, that enable rich consumer information rights on chemical in article by the IT tool. LIFE-WEMER is a project aiming at the integration of different software for the risk assessment of risky substances. So these are some of examples of projects currently being implemented. So, and that's all. Thank you for your attention. Do you have any questions?
Okay, thank you very much, Manuel. We will take the questions to the chat and respond them during the Q&A session. Now the next speaker is Dunja from EURATEX.
Thank you.
Dunja.
Good morning.
Good morning.
I'm just going to share my screen. Let's see. Can you see the screen?
Yes.
Very good. On full mode. Just give me a minute. Perfect.
We see the slideshow with the presenter view.
You see now the first slide.
No, the presenter view. So I see the notes and the next slide and everything.
Mm-hmm.
You have to show it as a single monitor.
Just a moment. Maybe I could do it like
Duplicate
this.
the I think you should.
You still see it?
You need to duplicate the instead of extend it.
I see. Well, I hope that people have empathy for technical issue during this crisis. I think we're all in the same boat. Is it okay now?
No, maybe you can start again the presentation, so it will appear nicely.
Just a second.
No, it's still.
Hmm.
If you click on display settings on top, duplicate
Yes.
Slideshow. Yes, now perfect.
Perfect.
Okay.
Great. Well, sorry for the delay.
No problem.
Good morning, everybody. Thank you for the FLAREX team for inviting EURATEX to give a short overview of the challenges, what we're facing over the years on multiple chemicals policy initiatives, and also way forward on substitution. My name is Dunja Drmac. I'm the Senior Policy Officer at EURATEX, European Textile and Clothing Confederation. Just a moment, let me move this. As you can see, the industry is quite big. It's quite sizable. The European industry, textile and clothing industry, has a turnover of around 178 billion of euros and has around 171,000 companies, representing different manufacturers of textiles, not only fashion, but also home textiles, technical textiles, personal protective equipment, and also medical textiles. What we've seen that it's a very important niche during this crisis. So we are the voice of the European textile and clothing industry before the European institutions. Here you see on the screen Council, European Parliament, and the Commission, and also beyond the United Nations, at the OECD as well. Moving ahead, we've seen many reports and many conversations talking about textiles being made in the Far East, in Asia. And we really want to break this myth by representing this figure that actually the European Union supplies textiles to the world, as you can see from the infographics. And on the left-hand side, you see different products that are made in Europe. For example, the Spanish company Textiles Catarina produces sustainable textiles made of organic cotton, recycled polyester. It's also made in Spain. We also have companies producing medical textiles that need functional specialty chemicals for properties and for safety. And we also have innovative companies who are looking into alternatives, for example, for repellency, such as, for example, Sympatex. But this is only for some type of workwear and also for limited standards. 2 years ago, we said that we are an industry that is stuck in the middle, and we are stuck between a hammer and an anvil. We are stuck between growing regulations, growing REACH restrictions, and also customer demands for water repellency, oil repellency, different safety standards that require these specialty chemicals. And 2 years after, we see that the hammer is getting bigger and bigger. You can see here different textile-related REACH restrictions. Recently, we dealt with a group restriction, such as on the CMRs, that tackled consumer goods, and they addressed 33 chemicals. Now we are dealing with even a bigger restriction on skin sensitizers that at the moment is looking at 94 substances, but with its particular dynamic link with CLP, it might even tackle hundreds or thousands of substances. And of course, the speakers before and also the upcoming speakers will also tackle the PFAS-as. For us, PFAS-as are quite important. We understand that they're hazardous and harmful, and they have to be replaced where they can be replaced, for example, in apparel that doesn't need special performances. But in certain situations, these substances are quite essential. And there are many, many initiatives ongoing. We've seen the PFOA restriction since it started in 2016, ended in 2018. We've then seen its reflection in the Stockholm Convention. And we also see ongoing initiatives like the restriction on C6, like the PFAS initiative by the member states, and also the study that is coming up. So there is really a lot going on. And we also see the new chemical strategy, which, as the Commission was saying, it will be a game changer. And I also echo these words in my presentation as well, because it will be a first big chemicals revision and almost the start of a new era in chemicals policy. So we see that all these initiatives are really putting a lot of pressure on the downstream users like the textile industry. And in the experiences that we had with these restrictions and the conversations that we had with policymakers is that we needed to explain the different needs of textiles. We really needed to explain that textiles are not only apparel, it's not only a jacket. And a baby jacket or a jacket for jogging is not the same as personal protective equipment or uniform for firefighters, which is also textiles. But this uniform is not chosen or not appreciated for its color. It's actually chosen for its functionality and for safety that will protect the worker. So for example, during the C8 restriction under REACH, we really needed to expose these technical difficulties of different alternatives and testing different alternatives on different fabrics. And how will these alternatives interfere with, for example, flame retardancy? And we also had to expose the sector complexity because it's a very complex and globally integrated supply chain. We also had to show the need to avoid regrettable substitutions, which I'm sure you are all aware of. And we also needed to expose the challenge in explaining these sector needs to policymakers, that safety standards from the customers are are dictated, and these are essential for worker safety or for the performance, for example, of an wings of an airplane, which is technical textiles as well. In the CMR restriction, which I mentioned in the previous slide, on the which addressed 33 substances for consumer goods, we really found it very useful to have this workshop in the middle of the regulatory process, where different industries, the NGOs, Commission, and ECHA were all at the same table, and we had a very good discussion and technical discussion on different thresholds, on different analytical methods. And this is where we really show the actual value chain needs on different kinds of thresholds for different kinds of textiles. And of course, we also have to mention the 2017 workshop that we did with the MIDWOR project team. And this workshop gathers different stakeholders from the textile value chain, from the chemical industry to academia, to testing centers, to us, the textile industry. And here we really talked about the different challenges of substitution of PFAS-as. And that was really interesting because everybody had their vision from their own perspective. And this was really, really important to gather everybody together. And what do we do now to respond to all these PFAS challenges, to this big hammer, PFAS hammer that is coming down on the textile industry? We are mapping out all essential needs of different types of textiles, substitution efforts. So what do the companies have been doing throughout the years to find the different substitutes? We have many evidences of that. Different types of research, like for example, the FLAREX research, or EURATEX or MIDWOR, and different types of standards that are required. And without these types of chemicals, these standards would not be able to be met. And with this exercise, with this database, we are explaining what we really need. What are the essential uses, and what are different types of textiles, and not only apparel, like many people think. So to go quickly on the conclusions, we see that regulations are arriving faster than solutions on the shelves. And what we mean by that is that there's so many restrictions, and so, like you saw in the previous slide, but we don't have alternatives. We do not have suitable alternatives to replace these types of chemicals that also have the same performance. And this crisis, unfortunately, exposed our great dependence of the healthcare system and also the general public on medical equipment. And we really need to work on the EU strategic autonomy. And this is something where the Commission also mentioned, and this is something as well that the roadmap on the chemical strategy addressed. And as you see from the slide here, that the WHO also exposed this problem of the shortage of personal protective equipment that really puts in danger the healthcare workers worldwide. And for this type of equipment, we do need harmful chemicals, unfortunately. And Commissioner Breton said in his hearing that we need to work on ecosystems, the 14 ecosystems, and textile ecosystem is one of them. And for that, we need global rules as well. And textiles, the European textiles represents 3.5% of share of the European chemical industry. And while this may sound small, if you look at the figure, actually we are fourth of all the industries. But for that, we need breakthrough research. We need breakthrough research to find alternatives. And we see textile sector as to having an untapped potential. And the chemical industry and the collaboration between the downstream users like textiles and the chemical industry to find these new alternatives to manage the breakthrough research is really necessary. So we really want to see that the FLAREX outcomes support this, also our conclusions. And maybe to leave you with the question, we very much appreciate the efforts done in projects like FLAREX, in projects like MIDWOR and EURATEX, and all the other projects looking at substitution and different alternatives, because these are technical evidence that we also use to see what works and what doesn't work when substituting in different types of textiles. And with that evidence, we need to go to this breakthrough research. We need collaboration with the chemical industry to be innovative, just like we see on the first slide, and also to make the supply chain shorter so that we do not have to depend on the imports of medical equipment, but we can also have the autonomous supply chain here in Europe. And with that, I wish to thank you. Here are our members, and in case you have any questions, you can send it on chat or also send me an email. Thank you.
Thank you very much, Dunia. We will continue now with a presentation from Maria from ECHA.
Hello, can you hear me?
Yes.
Excellent, okay. So you're showing the slides, aren't you? Yes.
Yes.
Good. Okay, good morning, everyone. Thank you very much for the invitation to present here. My name is Maria Tati, and I work for the European Chemicals Agency. I work on risk management. I'm going to be talking about substitution of chemicals. I'm going to be covering early warnings, concepts, and available tools, and making a note as well at the end on the status of PFAS restrictions for textiles, as has been previewed by a couple of other presenters earlier. And I should note as well that in keeping with the theme of substitution of my presentation, I am here substituting for my colleague Denis Motet, who's the lead in substitution in ECHA. So it's possible that I may need to take away some of your questions and bring some responses later once Denis is available. Okay, please, Josep, could you move to the next slide? Thank you. Okay, so a quick reminder and on the link between the project and what I'll be talking about. We know that several flame retardants or synergies are hazardous and they're subject to regulatory risk management measures, or they are under regulatory scrutiny, as has been mentioned. So there is an obvious need for safer alternatives. And we know as well that there are various potential alternatives that exist, but in order to find the right ones for particular uses and avoid regrettable substitution, it is well known that well-conducted hazard assessments and technical feasibility testing are key. The other concept that I think is interesting in this case is the idea of functional substitution. So the idea of not just looking at a drop-in alternative of changing to another substance, but also looking at a broader range of alternatives, including starting from the function of the substance, not just the substance itself. And we are very happy that FLAREX addresses all these aspects, and with an approach that is endorsed by ECHA in its substitution strategy, which is the active involvement of stakeholders, including, as it says here, centers of expertise and textile manufacturing companies. Next slide, please. Thanks. Oops, I think we've skipped to one. Thanks, that's the one. So the other thing I wanted to highlight is that you may be familiar with this diagram, which comes from occupational safety and health, which is the hierarchy of controls. And there are some that are much more effective than others, with the least effective being PPE. So we focus here, I think, in this project, in the first two, which is the ones that are most effective, which is the elimination, which basically means, can we physically remove the hazard? Can we eliminate the need for the functionality? And also on substitution, of course, which is, can we replace the hazard? Can we find something better to achieve the same function, whether it is another substance or something else? And can we move to the next slide, please? So we're now moving on to the tools that are available. And this is tools that are available for stakeholders to be warned in advance of regulatory measures under consideration, so that regulation does not come in as a surprise for them. So we have got many different stages in the whole process, from first starting with compliance check and testing of proposals, then preceding regulatory risk management process, then the actual regulatory risk management process, and with those who are going from early warning to serious warning, and then finally the outcome, which is the actual the actual regulatory the other regulations that we need to comply with. If you go one step further, please, Giuseppe, there's we wanted to highlight a tool that we have in ECHA. If you click once, there we go, which is called PACT, which stands for Public Activities Coordination Tool, where you can find all these processes that are within the box that has just appeared on the screen in one place, and you can see the link below. So you can go there if you use a particular chemical and find it there and find out what is going on in the regulatory world with it. Can enter the CAS number, for instance, and find all that is going on and where it is. That way you can hear about scrutiny that's going on quite early, and as we said, it shouldn't come as a surprise. Also, of course, there is our landing page on the ECHA website on information on chemicals, where there is a lot of information as well there. And let's move on to the next slide, please. The other concept that we wanted to highlight is that in our substitution strategy, we find that stakeholder engagement is key, and ECHA provides support to people wanting to organize substitution supply chain workshops, and we've got a list here, and I think there are links, so you should be able to click on them when you receive a copy of the slides, talking about the different workshops that we have had, or I think some of them actually, I think there may have been more, and these have been organized in many different places, as you can see. The one in Belgium in 2018 was the first FLAREX one, and there's one also, of course, very relevant that was planned for Paris this year. With the obvious things that are going on, that one is a little bit up in the air, but well, we should go back to planning relatively soon once things are a bit clearer. Let's move on to the next slide, please. And in addition to support to substitution workshops, ECHA has made this online training on AOA and substitution available for companies to use. It is an introduction, but it is actually quite complete, and there's a lot of material there. And we invite companies to use it and take this training. It's free to do, although there is some registration needed before, so we're working on transferring the material to the ECHA YouTube channel so that it's available more easily and for more people. And we are very interested in hearing feedback on it, both on the training that is there and on potential additional training that may be interesting for people. So we might think of producing some of that. So whether it's something that's maybe a little bit deeper, going beyond this introductory material like comparative assessment or economic assessment, or whether it's slightly different topics that people would like covered. So we encourage you to have a look at that and let us know your thoughts. Next slide, please. Here we've got some networks, information, and funding sources. I'm not going to go into detail on these because obviously I'm sure some of these at least will be covered or have been covered already. And of course, these are links, so when you have the slides, you can click and find out more. So this includes things like providers or buyers of alternatives, or where you can find funding and that kind of thing. Next slide, please. And of course, we have got quite a lot of information in general on the ECHA webpage without having to go into the actual training. So a lot of resources available there. This is, as you see, the landing page. There's links to all the workshops there on the supply chain workshops that I mentioned earlier, in addition to the ones mentioned in that slide. Information on networks, on funding and technical support. Also data to prevent regrettable substitution. So again, we encourage you to explore the resources available there and make good use of them. And yes, I think that covers what I wanted to talk about on substitution. So if we go to the next slide, please. I'm going to be talking a little bit about the status of PFAS restrictions on textiles. So let's move on to the next slide. As you know, and as has been mentioned, the concern with PFAS is that they are highly persistent, that they can contaminate groundwater and drinking water, and that certain of them accumulate in the bodies of living beings, and they can cause toxic effects. So therefore, they are currently subject to several regulatory initiatives for different sectors, and these sectors include textiles. Some of these have been mentioned already, particularly by Dunia just now. There's PFOS, PFAS, and related substances. There are some derogations for textiles there. C9, C14, PFCAs, and related substances, those are all there. Now some newish developments. We have got PFAS and related substances that has just been adopted at the committees now in June, so should be sent to the Commission very soon. And then there is PFAS and related substances, which is a proposal from Germany that has just started opinion making. And I should note on that one that the consultation is ongoing. And of course, we have received already quite a lot of comments, but it's ongoing until September. So we encourage people to send data there. We are having a look at them in quite a lot of detail. A lot of the things that Dunia just said about PPE, for instance, we have received a lot of very, very useful information on that already as well. As well, I should mention that there is a link there to an overview presentation from an OECD webinar done this February, which you can have a look at. And there's more detail on all these measurements and initiatives that I have just mentioned. And there is a lot of information as well, of course, on ECHA's PFAS webpage. If we move on to the next one, please, next slide. This has been mentioned already by Katerina, of course, the joint member states initiative on a wide PFAS restriction proposal. It's being carried out by the Netherlands and Germany with support from Norway, Denmark, and Sweden. And these countries have shown interest in preparing a restriction proposal. And this is to cover a wide range of PFAS uses, including textiles. And where we are at the moment there is that the member states are organizing a call for evidence to get more information on things like uses, tonnages, alternatives, etc. This is already live. It has been from the 11th of May, and it will be open until the 31st of July 2020. I've included there the link to where the consultation, not consultation, sorry, this call for evidence is cited. So as I said about several other things already, I encourage people to engage with that and to provide the information so that the restriction, when it comes, the proposal is as targeted as possible and has all the evidence needed. And yes, I think that is the last of this section. So if we go to the next slide, I think that's got my take-home messages for today. So as I said, there are several substances of concern used in textiles that are undergoing regulatory actions. So it's time to think about elimination, substitution, and safe and sustainable by design, always as early as possible. So we encourage people to watch the regulatory developments and also to contribute to surveys, calls for evidence, and public consultations. And also, even if there is nothing going on yet, to keep an eye on the available tools that we have on our website to find out if there's any regulatory scrutiny that is just starting out, so that anything a bit more serious doesn't come as a surprise. And yeah, with this, I've finished, and thank you very much for this, and I'm happy to answer any questions that I'm able to in the Q&A section, and of course come back to responses from Denis. Thanks.
Okay, thank you very much for your presentation. Now we are going to move to our next speaker, Anna from ChemSec. I just give you the role for sharing the screen. So you can activate the... Hello, Anna.
Hello, do you see my screen?
Yes.
And did you see the slide or me, or both? Is
Both.
it good?
Yes.
Okay. Okay. Thank you very much for the invitation. I think it makes perfect sense to go from the nice ECHA presentation into some tools for substitution that we have at ChemSec. This funny picture is from a small commercial we made about the SIN list, which I will also talk about further on. So just very briefly, I'd like to present our organization because we are an environmental NGO, so that's a bit different. We're based in Sweden, and our strategy as an NGO is to align with progressive companies and show positive examples. And we work only on the issue of hazardous chemicals. And so the positive examples are from that sector. And that's also why we have developed these tools where we'd like to spread this information further. And we work in different areas. We work also with policy. So we are engaged, especially in the REACH process as stakeholders in different ECHA committees, for example. We have a business group of companies that I will show you soon. We also work a bit to advise financial investors on the issue of chemicals. And then we have the different tools. These are the companies in our business group. Our business group is a group where we discuss a lot chemicals management to exchange experience from each other for us at ChemSec to learn what companies need and see if we can help out somehow with developing some tool or some guidance. And this is sort of our reality check for our tools as well, that the companies in this group find them useful. And many times our tools are a result of discussions we've had in the group. And so the SIN list is such an example, and also the marketplace, which I will talk about. And so today we have actually a number of tools. We started off with the SIN list, and there are some linked tools that are linked to the SIN list, such as Similarity and SIN producers. A few years ago, we made a textile guide as well, which is about basic chemicals management in the textile industry. We have not updated it much the last years, but the basic information I think is still relevant and useful. And actually yesterday we launched our final tool, or our newest tool, called ChemScore, and I will present that very briefly because it's mainly for investors, but it might still be interesting for you just to know about it. So to start with the SIN list, this is our first tool, as I said, and we launched it in 2008. And it was actually also a request from the business group. This was the early days of REACH, when there was the concept of the candidate list, the SVHC candidate list existed, but there were not yet any substances on that list. And the companies asked us what substances we believed would be on the REACH candidate list. And so that exercise we did, and we then put this list of chemicals into a database. And through the years, we've had a number of updates on the SIN list with the aim of trying to predict the development of the candidate list and to also influence the development of the candidate list. So we have spent quite some effort to try to be sort of just ahead of the development. And we've had a number of updates reflecting that. So for example, in 2011, we added endocrine disrupting chemicals, which was very much discussed at the time and still are. But that was quite unconcrete what those chemicals would actually be, which chemicals companies would need to focus on to assure to not have endocrine disrupting chemicals in their products. In 2014, we had an update with a focus on regrettable substitution, something that has been mentioned here, where we also launched our Similarity tool, which is a tool where you can enter a case number and see if a substance is structurally similar to a substance on the SIN list. And that gives a warning flag that it might have the same hazardous properties, although we do not know that, but that at least you should investigate this chemical more carefully before use. And we recently in fall now had an update where we added also very persistent chemicals, such as has also been mentioned here. So not only PBT chemicals, persistent bioaccumulative and toxic, but also the newer concept that has been promoted especially by Germany and UBA, taking into account also the mobility in water. So very water soluble, very persistent chemicals called PMT. And we know that the tin list is free of charge, and so far you do not need to log in or anything to use it. So therefore we do not know exactly who uses it, but we know from people that have told us or that we've heard. So our companies in the business group, of course, use it, and also a number of other large multinational companies and brands. And we know that ECHA and other regulatory bodies look at the substances on the sin list. There has been some reports about that as well. International organizations such as UNEP, who has listed especially the EDCs on the sin list as a very useful source of information on endocrine disrupting chemicals. Financial investors are interested in not doing investments that are bad in the future, and we've just seen recent examples of that with PFAS producing companies such as DuPont and 3M being liable of huge amount of money now in the US for remediation and for other things. And to be able to predict that is of course important for financial investors. We know that procurement agency and procurers use the sin list as well, and it's induced in or included in a number of different software systems where customers have asked for that to have a better check on their chemicals. Other NGOs that we know, or other fellow NGOs, use the sin list when they campaign about different chemicals for different reasons, and also producing apps like ToxFox or Kemilupen or similar. They use the sin list again, and so does a number of eco labels and certification schemes. So the main reason for all of these to use this sin list is to try to stay ahead of regulation and be one step ahead. And this is 1 year back from now. In this year, we've had 28,700 users, and it's almost always that the second largest country is the United States, where the users come from. And this year it was France in the top. That varies a bit, but we can also see that we have users from Japan and China, which we think is also from supply chain requirements from these companies. And the marketplace was mentioned also by the previous speakers, and this is our platform for showcasing safer alternatives. This was also a request from the business group. They were tired of, they have all long lists of chemicals that they would like to substitute, and they were tired of always having to go back to their supplier with specific questions for specific chemicals they wanted to substitute. And they say, can't there just be a place where we can see all of the alternatives at once, and we can sort of choose where we'd like to start? And that is what we try to achieve with the marketplace, to have this window shopping opportunity of alternatives. We also sometimes call it a dating site, because it's about getting a first contact with between suppliers and users of alternatives. It's about them to connect, but you don't buy any chemicals on the marketplace. You just make a first contact between users and producers of alternatives. To advertise on the ChemSec marketplace, if you have safer alternatives to a hazardous chemical, and I can imagine that there have been some such in this project, I'd like to hope so. We accept alternatives that can be drop-in substitutes for chemicals, but also alternative materials or technologies and other types of solution that can make you able to avoid a hazardous chemical. And we also have criteria then for what is safer to avoid this regrettable substitution issue. It is up to the provider of the alternative to assure safety and to sort of promise that their chemical does not fulfill these criteria. We make a basic check, but we do not spend extreme amount of time of this that would be needed to really for us to be sure. So therefore that responsibility lies with the producer. And if we look at the numbers here, we are approaching 300 ads on alternative products from about 150 companies. There is also the possibilities to post request if you are lacking an alternative and interested in finding one. So we have 30 different requests on Marketplace. 20 organizations and companies that support the initiative, meaning that they find this useful and they hope it to grow. And right now we have about 2,000 ads viewed per month, and we have a newsletter as well. So you're very, very welcome to sign up to. And as I said yesterday, actually, we launched our latest tool, which is called ChemScore. And that is a project which is completely new, and which was also the request from a financial investor that would like our opinion on which chemical producers are the most sustainable ones when it comes to the issue of chemicals. And so we have made this exercise using the information on the web pages of different chemical producers, and also given them an opportunity to complement with further information, and scored these companies based on 4 different points. So what hazardous chemicals, that means what sin list chemicals do they produce, with a special focus on persistent chemicals. Is there a program of development of safer alternatives and safer chemicals, and are they marketed on the web page? And how transparent is the company in terms of chemicals management and other issues? And there is also 1 point on controversies. For example, if there have been large pollution scandals or similar from factories and so forth. So that's our brand new project right now. And with that, I'd like to thank you for your attention, and I'm also happy to answer any questions in the chat or at the Q&A session.
Thank you very much, Anna. So now we are going to go ahead with the presentation of the LIFE-FLAREX project, but before, I would like to share a small video about the project.
Fire. We think that these kind of things are never going to happen, but unfortunately they do. In order to avoid tragedies, we need to protect our buildings to prevent fire from going from spark to disaster. One of the major products of concern are textiles. They burn quickly and easily spread fire, hence we need protection. For a long time, most fire retardant additives used in the market have not been questioned because they work rather well. However, many of them have a dark side. They are toxic both to humans and to the environment, and this is bad. We need safer flame retardant additives that are human-friendly, non-toxic, and safe for the environment. The European Union will ban most toxic products to protect its citizens, but at the same time, we need solutions to be safe. In order to address this, AEI Textiles started the LIFE-FLAREX project with the aim to demonstrate that safer additives are possible now and to support companies making the transition to safer products. AEI Textiles partnered with other innovation clusters across Europe, Adeval, Pointex and Clutex, and with top research institutions, LEITAT, Centexpel, and the Institute of Advanced Chemistry of Catalonia. Research institutions are assessing alternative products in terms of technical performance, sustainability, and human safety, whereas clusters are engaging the industry to raise awareness and consciousness. This cluster-driven initiative is key in bridging the gap of innovation to industry to enable a safer and greener future. With the contribution of the LIFE program of the European Union.
Okay, so now we are going to go with the presentation of the different results of the FLAREX project. I'm gonna share the screen with Maria and Ine, who will start with the presentation. So Maria and Ine.
Okay, thank you. First of all, can you hear me? Because I had some
Yes.
connectivity issues today. Sound
Yes.
is good? Okay.
Yes.
So this video gave a nice general introduction to the project, but we would like to go more into detail now on the technical outcome of FLAREX. So please, next slide. Okay, so let me first explain how we proceeded within the project. So we first started with the selection of fabrics and flame retardants. For the flame retardants, we did the pre-screening of commercial products. So we made a state-of-the-art of available flame retardants, but also looked at their environmental considerations. And from there, we made product selection. We also selected some fabrics like cotton and polyester, which are the most used materials. And this was also evidenced by a questionnaire we performed. And then we applied the flame retardants on those fabrics at lab scale. The most promising solutions went then to an industrial application. During the industrial application, also people who performed the life cycle analysis and the risk assessment were present, so they can use this as input for their studies. Also toxicological tests were performed, so skin penetration tests also, and this also served as an input for the risk assessment. And of course, we did a complete technical evaluation of the fabrics produced at industrial scale. And during the project, we also held quite some workshops and we did quite some communication with the main goal to have policy recommendations at the end of the project, but also to inform industry. Next, please. So here you have an overview of the fabrics we selected. So we have four main domains in home textiles: upholstery, curtains, mattress sticking, and bed linen. So for the upholstery, used polyester fabric of 320 grams per square meter. For the curtains, also polyester curtains, but a heavier weight and a lower weight one. For the mattress sticking, we used two different fabrics, a spacer fabric made out of 100% polyester with a high grammage of 266 grams per square meter, and also a polyester cotton blend of 50-50. And then the bed linen, also we used there two fabrics, cotton fabric and also again a blend of polyester cotton in 50-50. And they both have a grammage of 112 grams per square meter. So for the flame retardants, we divided it in three main categories. So we have the conventional flame retardants, so the ones that are used nowadays. So we have the halogenated one, which is a decabromodiphenyl ethane, which is currently used often. We have the halogenated one in combination with antimony trioxide, because this is used as a synergist for the halogens. And we've also evaluated formaldehyde releasing treatments like the EURATEX. Then we have a transitional solution. It's still a halogenated product. It's a brominated polymer, but because it's a polymer, it has less tendency to migrate into the environment. So it's considered to be a safer alternative to the small molecule, the conventional ones. And we also selected some alternatives based on phosphorus or nitrogen, also other chemistries like expandable graphite and so on. So we might quite some diversity in the different chemicals. I will go more into detail on the chemicals later on. Yes. So for the industrial applications, we partnered up with Tintatoria Finissaggio in Italy. They applied the flame retardants on mattress sticking. Bonditex in Spain did the upholstery fabrics together with Pertex in Spain. Then Finistampa Giordanetto in Italy flame retarded the bed linens, and then EASME also did a mattress sticking. And then EURATEX together with Tilex in the Czech Republic treated the curtains. So considering the fire test for mattress sticking, we always perform the EN597, the 1 and 2. So that means ignition with a small flame or with a cigarette, as you can see in the pictures. And we also performed the BS6807, so the CRIP 5, as you can see on the lower picture. That's where you put a stack of wooden sticks into fire. Then for the upholstery, we performed the EN 1021. Then you mimic some kind of sofa, and you also set it on fire with cigarette and flame. And before the fire test, the fabric was soaked for 30 minutes at 40 degrees Celsius. And then for the curtains, we performed the EN 1101 and the 13772, and we washed it one time at 30 degrees before the fire test. And then finally the bed linen, there we did the ISO 12952 one. That's quite comparable with the mattress sticking, so also with a small flame and a cigarette ignition. But here, before you do the fire test, you wash the fabric, in this case 5 times at 60 degrees Celsius. So when we look at the mattress sticking, we evaluate the decabromidiphenyl ethane with and without antimony trioxide. So once in combination with melamine cyanorates and then with the ATO. So you have a color code. So the blue ones actually all passed the lab scale fire test. And then the green one, they also passed. And these were also then tested at industrial scale. So as you can see, actually for the mattress sticking, the conventional one as the transitional one, the polymeric flame retardant passes the test. But I have to say this stiffens the fabric a little bit in this case. So this is a drawback. And then for the alternative flame retardants, we assessed ammonium polyphosphate, guanidine phosphate, and ammonium sulfamate. They all passed the fire test very well. Just maybe a small comment, ammonium polyphosphate needs the highest amount, so it stiffens the fabric the most of the 3 treatments. Below you see some pictures. So when you look at the cotton polyester, the flame test, when it's untreated, it's fully burned, and when it's treated, you only see some very small marks of the cigarette and the small flame. And then for the polyester fabric, which is also already quite flame retardant on its own, you can see by applying the flame retardants, we can improve like the grip 5 ignition. You see the burn marks are much smaller. When we look at the bed linen, there we tested T-alkyl phosphonyl carboxylic acid amide, so that's the EURATEX process. And again, we applied the 2 conventional treatments, decabromidiphenyl ethane with and without antimony. Again, we did the polymeric flame retardant, and as alternatives, we assessed a blend of ammonium sulfamate, urea, and a phosphorus-based compound. And then the tetrakis hydroxymethyl sulfate. And then for the cotton one, we did a third one. It's a priority phosphorus-based material. So what we can say is that in this case, the decabromidiphenyl ethane treatment did not pass the fire test because it's washed off during the 5 washing cycles. The EURATEX that is covalently linked to the cotton part of the fabric withstands the washing, that's no problem. Also the polymeric flame retardant passes the fire test, but the blend we tested was still too much stiffening the fabric. And then the blend with ammonium sulfamate and phosphorus-based compounds nicely passed the fire test. But then we need an adapted rinsing procedure with ammonium sulfamate, especially in the case of the blends with the cotton polyester, because we have quite high polyester fraction. So what we can say in general, that for this application where we have quite some washability demands, that the number of possible alternatives are more limited, especially for cotton polyester blends where you have a higher content of polyester.
So now regarding the results in curtains, we have tried also 2 conventional flame retardants, the decabromidiphenyl ethane with melamine cyanoate and also with antimonium trioxide, but only the one with antimony trioxide worked at this lab scale. Then for transitional, also the polymeric flame retardant didn't work. So we only took one alternative that worked correctly to the industrial level, which is an organophosphonate, which we called number B. And we can see down in the slide some of the photos from the fire test from both fabrics, the low density and the high density fabrics, and we can see that the alternative is the one that passes all the tests. So finally, for the upholstery, we tried also the same conventional flame retardants and the transitional, And in this case, all of them passed the fire test at lab scale. And also for the alternatives, we used that organophosphorus salt that did not pass the fire test, and expandable graphite as a second alternative that did pass the fire test. And so in this case, we took all the treatments that work correctly at lab scale into the industry, just to be able to compare the results from an industrial level. So here you can see the results from the industrial trials, where we can see that the standard fabric, that is the one without treatment, was almost completely burned, and then all the treatments that work correctly. So now that we have presented the technical part, let's see the toxicological tests.
So this aside consists of determining the amount of compound that can penetrate the skin in order to calculate the level of risk in human health in use condition. In the next slide, there are the selected fabrics. Please. Okay. In this case, tested fabric are those that have direct contact with the skin in their use, upholstery, matting, and sheets, product of both conventional and alternative in different fabrics. First, dermal absorption. In the next slide. Thank you. Dermal absorption was obtained using an in vitro methodology with Franz static diffusion cell. In this test, textile was applied direct to pink skin, and after time of exposure, the compound was analyzed in the different skin layers. The amount detected in epidermis, dermis, and systemic level is considered as penetrate. In the next table, there is the dermal absorption value of all tested fabrics in different uses. Alternative is are indicating in color. And the penetrated amount combined with condition of fabric use of surface skin and frequency of contact with the skin, plus toxicity of each compound, the margin of safety can be calculated. Next, as you can see, all fabrics were appropriate under this condition of use, except ammonium sulfamate in bed linen with a laboratory treatment, but when it checked with industrial treatment, result was accepted.
In terms of risk assessment, the methodology which was used for the assessment was in line with the REACH regulation, and we were supported by the guidance which were developed by ECHA in order to perform the assessment. This assessment was developed in 3 steps. First of all, it was perform an assessment from the occupational side, where we evaluated basically the risk posed to workers by 2 routes of exposure, inhalation and dermal exposure, and we took into consideration the operational conditions and the risk mitigation measures implemented in the industries where the industrial trials took place. In a second step, it was perform a consumer risk assessment based on the risk posed to final users, considering the pattern of use of the different textiles. And finally, we perform a third risk assessment, the environmental one, based on the risk posed to 6 environmental compartments. We are talking about fresh water, marine water, sewage treatment plant, sediment to fresh water, sediment to marine water, and soil. And in order to consider a formulation as an alternative for substitution to the conventional ones, all the 3 analyses must lead to a safer conditions, marked in green in the following tables. So if we focus on the results for the different flame retardant formulations tested, we can affirm that in case of curtains, the organophosphorus A and organophosphorus B formulations will be a suitable alternative for substitution for the conventional ones. In case of upholstery, the organophosphorus salt and the expandable graphic formulation will be an option. Next slide. In case of matrix thickening, we have two alternative options which will be suitable, the ammonium polyphosphate and the ammonium sulfamide. And in case of bed linen, we have another two options, which will be the ammonium sulfamide formulation and the one which includes a phosphorus-based compound as active ingredient for flame retardancy. Now my colleague will talk about the life cycle assessment.
Thank you, Ruben. So during the project, we developed an environmental assessment of the different flame retardants following the life cycle assessment approach. And the aim of this LCA, of the life cycle assessment, is to evaluate from an environmental point of view the impact associated with the global life cycle of the flame retardants tested in the industry. And moreover, with the LCA, we have calculated the benefits from the substitution of the halogenated flame retardants commonly used in household textiles for the alternative proposed during the project. To compare the flame retardants, we defined a functional unit, which is the 100 square meter of textiles finished with flame retardants. And in the system boundary of the project, we include the raw materials used to formulate the flame retardants, the manufacturing of these flame retardants, the textile treatment, the use phase, and the end of life. If we look to the results, okay, in this graphic, we include the total impact of the different products. And in average, the conventional flame retardants have a higher environmental impact than the alternatives of the alternatives selected during the project. And moreover, we can see that the inclusion of antimony trioxide in the formulation of the flame retardants or in the treatment of the textile increase the environmental impact of the product. For this reason, the elimination of this substance during the treatment of the textile is important in order to reduce the global environmental impact of the product. On the other hand, the best environmental solution of the project or of the alternatives selected during the project are the flame retardants based on ammonium sulfamide and ammonium polyphosphate. And in the next slide, thanks, we see that the contribution of the different life cycle stages in the different alternatives and flame retardants tested in the industrial trials. As can be observed, most of the alternatives selected during the project are more affected by the textile treatment than by the flame retardant production. A lower contribution of the production stage is related with the best environmental performance of the product, and this means that an optimization of the textile treatment could reduce the environmental impact generated during the life cycle of the product or of the flame retardants in this case. So the introduction of industry energy efficiency measures can improve the environmental performance of the flame retardants. And to complement the environmental assessment, we made also an economical assessment following the life cycle costing methodology. This methodology includes the assessment of the direct cost and the indirect cost. The cost included in the direct cost are those related with the acquisition of the flame retardants and other chemicals used during the project or during the textile treatment, and the cost associated with the textile treatment and the flame retardant application. After that, on the other hand, the indirect costs are calculated, converting to monetary terms the externalities quantified during the life cycle assessment. In the next slide, thanks. We present here the direct cost of each flame retardant tested during the project. The The products with better economical performance are the ammonium polyphosphate and the organophosphonate salt flame retardant. Both of them are alternatives selected during or proposed during the project. And the cost of these products is 10 times less than the most expensive flame retardant. And finally, in the next slide, we present the result of the indirect costs. As can be seen, the halogenated flame retardant used with antimony trioxide is the product with the highest cost. The mitigation of the environmental impact associated with the flame retardant formulated with antimony trioxide will cost 56,000 euros, and this means that this cost is 5 times higher than the cost associated with the mitigation of the environmental impact of other flame retardants. And finally, I only say that the best economical solution is the ammonium polyphosphonate product, which cost is lower than 600 euros. And now we'll pass the floor to my colleague.
Hello, good morning. The policy we have reviewed the draft currently under revision to propose recommendations for updating it. As general recommendations, we would like to include recommendation in Chapter 2 related to coating and laminating processes and flame retardant treatments. Taking into account the project results obtained after performing tests at lab and industrial level, we have proposed recommendations in Chapter 4, 5, 7, and 8. In Chapter 4, to include the description of organophosphorus compounds and expandable graphite as flame retardants alternative tested, and include them on table 478 about hazard profiles of alternatives to the decabromodiphenyl ether. Chapter 5 includes the info of the previous section 4, as BAT 49 is based on this information. And BAT 13 is included the regular check to identify new potential available and safe alternatives to the use of hazardous chemicals. In Chapter 7, we can recommend or other flame retardant alternatives for future work. This annex has not been reviewed yet. And finally, in Chapter 8, we will recommend to include a description of the organophosphorus compounds tested and the applications performed. Next slide, please. The conclusions are as follows. Along the 3 years of running project, we have demonstrated the technical viability and flame retardant properties of the different fabrics applications. The flame retardants alternatives based on phosphonitrogen and nitrogen sulfur compounds are viable for textiles application without washing requirements as matrix sticking. The phosphonitrogen compounds can be employed in application with wash-resistant requirements with a content of cotton as bed linen and curtains. For upholstery applications, the alternative flame retardant based on expandable graphite has good behavior and require high resistance to wettability. As regards of risk analysis, occupational, environmental, and consumer, the most viable alternatives have been evaluated, and the results are positive for the different applications. The transitional alternatives don't accomplish safety requirements. The risk characterization ratios are greater than 1. Referring to life cycle assessments results, the alternatives without halogens have a low impact compared to conventional ones. And finally, taking into account the economical aspect, we can say that the alternative products are competitive and can even lead to process cost reduction. Thanks for your attention.
Thank you very much, Julia, and all the team from LIFE-FLAREX. We will now move on to the next presentation by Ruth about the MIDWOR-LIFE project, and then we will take the questions shortly after the next meeting, the next presentation that will be from Ioannis. So, Ruth, the floor is yours.
Okay, thank you very much. Can you see my screen?
Yes.
Okay. So, yeah, my name is Ruth Garcia. I work at LEITAT Technological Center in the Dyeing and Finishing group. And today I'm here to talk a little bit about MIDWOR-LIFE project, where we studied the possibility to substitute the fluorinated products used in the textile finishing industry. And yeah, so let's start. When talking about DWORs, or durable and water and oil repellents, it refers to chemical products that are used in the textile finishing industry to provide water and oil repellency. And the problematic associated to these substances, as we have, as some of the speakers have already mentioned, is that the conventional DWORs used in the textile industry are based on perfluorinated compounds, mainly C8 and C6. And from the environmental perspective, the main concern raised by these DWORs is that each fluorinated chains may be severed from the polymeric backbone, releasing perfluoroalkyl substances. And later on, these substances will degrade into the environment to form highly persistent and bioaccumulative perfluoroalkyl acids, which represent a high risk both to the environment but also to humans. And during MIDWOR-LIFE project, fabrics representing different industrial sectors were selected for the application of the different products. These fabrics are polyester non-woven for the automotive sector, knitted polyester fabric for sports and t-shirts, for sport t-shirts, and workwear, and a woven woolen fabric for suits and woven polyester fabric for upholstery. In regards to the product selection, you can see it here. We can mainly divide it into two groups. The first one are the conventional perfluorinated compounds, where we included C8, C6, but also perfluorinated silicones. And for the non-fluorinated alternatives, we included silicones, dendrimers, or what's the same, that's hyper-branched polymers, and paraffin and alkyl urethane. These products were first applied by bedding on the laboratory scale, and then the most promising ones were applied also on industrial scale. So here you can see the technical results of the project. Just for you to know, the water repellency grade ranges from 0 to 5, being 5 the highest repellency. And in the case of oil, it's from 0 to 8, being 8 the most repellent. And except for the automotive fabric, the results presented here are from the washed or dry cleaned samples, and also ironed. So yeah, these are the results that are here presented. And also in bold are highlighted the results from the industrial demonstration. So let's talk about the results. In the first table, what we can see is that some alternatives can substitute the fluorinated chemistries if only water repellency is required. And especially the dendrimer can be a potential substitute, since it achieves the same repellency grade as the C8 in the knitted polyester fabric. And it should have been interesting to apply this product on the other polyester fabrics during the industrial demonstration, since in general the results are more reliable on the industrial scale and also tended to be higher. And regarding the repellency, only the perfluorinated compounds can provide this property, as you can see. However, it was proved that if we truly need this functionality, the C6 and the perfluorinated silicones can substitute the long-chain fluorocarbons with very similar performance. So what we recommend is case-by-case studies in order to decide if we truly need oil repellency. In regards to the LCA, you can see here the results. What we can see is that the highest impact is obtained by the perfluorinated compounds, although the C6 and the perfluorinated silicone present a lower impact compared to the C8. And if we have a look at the fluorine-free alternatives, we can see that they present a much lower overall footprint, being up to 30 to 45 to 40 times lower than the C8-based substances. And among these alternatives, the dendrimer and the paraffin present lower impacts than silicone. And in general, the impact categories that contributed the most to the overall impact of the DWORs are human toxicity and ozone depletion. So it was a very brief summary of the project, but what we have seen is that for applications where we only need water repellency, we have proved that there are high-performing fluorine-free alternatives with lower environmental footprint. And among these alternatives, the best technical results were obtained by the dendrimer. And regarding oil repellency, no fluorine-free alternatives can provide this functionality, but if it is essential, C6 or perfluorinated silicones are the options with the lowest environmental impact. So the MIDWOR-LIFE project proved that some alternatives can substitute perfluorinated compounds, but case-by-case studies are recommended to decide if oil repellency is truly needed. And that's all from my side. If you have any questions, you can put them on the chat or at the Q&A. And you have also here my contact and the project website. Thank you very much.
Thank you very much, Ruth. So now we are going with the last presentation from Ioannis Dostis from UA. You can share your screen. Hello.
Yes. Do you see my screen now?
Yes.
Okay, perfect. So let me just yes. Oh, that's perfect. Okay. Thank you for the invitation and the chance to present the current status of our project for AskREACH. It has already been mentioned by Manuel Montero. It has to do with development of IT tools with aiming at better implementation of the REACH regulation, specifically for Article 33. I would like to give a really short background first, legislative background. It's Article 33 is also known as the right to know, and it applies to any actor within the supply chain, any supplier, but also for consumers who have the option, the possibility to ask for information on substances of very high concern in articles and whether they are present there. And they are entitled to receive this information within 45 days free of charge by any actor within the supply chain that they ask of. And here, of course, when the concentration is above 0.1%, and here I would like to highlight also that with the term supplier, it's not only the producers of the articles, but also any other actor, importer, distributor, and retailers are also included in there. Our project involves 20 partners from 13 member states, and the consortium has regulatory authorities, agencies, institutions, NGOs, included, and the app is not only available in these 13 countries, but is also being transferred in other countries. You see Serbia, Lithuania, etc., and even more countries are interested in having the app transferred. It will eventually be available through the whole Europe. And the project runs until August 2022. We're looking into have submitted for prolongation due to the corona pandemic situation. The driving forces behind the project was, of course, the protection of environment and human health, and to promote the substitution of SVHCs in articles by, let's say, indirectly increasing the market demand for articles that are SVHC free or have less than 0.1% content. And of course, to raise awareness for suppliers and their obligations, and also raise consumer awareness and their right to know and right to request this information. The main pillars of the project involve the development of a smartphone application. It's called Scan4Chem. It's already available both for Android systems and iOS systems. So consumers can launch information requests towards suppliers, and a database that where suppliers can upload their SVHC article information. Smaller action also involves the development, well, not development, but it was handpicked with the aid of pilot companies, a supply chain communication tool, which belongs to Apon Systems, and it was optimized with the help of these companies. This action is still running. And of course, campaigns for raising awareness, consumers and companies. As I said, the smartphone application is already available in these countries. And very briefly, what the user can do after downloading is to scan a barcode from an article, or manually input the article barcode or the name. If this information, the SVHC information, is already available in the database, then it gets displayed to the user immediately, straight away, which means that the user does not have to wait 45 days for an answer, but can make a purchasing decision at that moment when he's at the store. And at the same time, the supplier does not have to deal with incoming information requests, and saves a lot of time by not having to respond to these information requests. If this information is not available, then the system generates automatically an information request that gets sent to the supplier, and here also retailers are included. Now for the database, there's already a platform, supplier frontend, where article suppliers can register and then upload their article information. And this information, as I said, is going to be displayed for anyone that scans one article that is of interest. The responsibility falls onto suppliers for the validity of the data that they provide, and also they are responsible for keeping the information up to date. As you know, the candidate list is biannually updated, so the information needs to stay also up to date from the article point of view. This is just a graphical representation of the system. I'm not going to go into that too much. Everything passes through the AskREACH system, but of course there is the possibility for suppliers to circumvent the system as well, and respond to an information request that comes their way through a simple email answer to the consumer. And the least thing that suppliers can do, and I would urge them to do, is to register at least in the AskREACH database, so that they can provide the correct contact details where the information requests arrive to, are delivered, and not to some researched address from any user that has they downloaded the app and wants to research themselves where to send the information request, so it ends up in different email addresses from a company who do not know what to do with it. Of course, then suppliers can claim their barcodes if they have barcodes, and associate the barcodes and the articles with their brand, with their company. And the best thing to do also is to upload information on their articles. This can be done either by manually entering each article, if the supplier wants to give extensive information on an article, or there's also the option for saving time to bulk upload information. There's an Excel template provided, which can upload up to 500-600 articles at once. A new feature that is implemented is also for companies that have extensive portfolios with articles. that are free from SPHCs to be able to declare whole ranges of barcodes that do not contain SPHCs. So that saves also a lot of time. That facilitates uploading information from companies. And at the moment, under development and in parallel to the ECHA database, the SCIP database, a Euclid format is foreseen. And that will also facilitate notifications from companies to the AskREACH system, since they will be obligated to do the same thing for the SCIP database, which uses the Euclid format. I've already mentioned. Yeah, I've already mentioned most of the advantages for the suppliers. I'm not going to go into these. Also, for the supply chain action, if someone is interested to participate, it's still running. I can contact our partner from Sofia, and it's free of charge for the project duration for the companies that are interested. The campaigns are starting again to intensify, both consumer and company campaigns after the corona pandemic situation, and a new up version is also will also be published now, released now in this summer. And a few statistics. So far, we had more than 35,000 downloads and 82,000 scans. Around 7,000 requests. Interestingly, around 40% of these had some reaction, even if an automated reaction from suppliers. And we already have around 17,500 articles in the database. So with this, thank you. You can download, of course, the Scan4Chem app. And if you have any questions, you can just contact me, go into the project website and have a look. And yeah, thanks a lot.
Okay, thank you very much for the presentation. Now we will have a brief Q&A session. If there is some questions, you can use the raise hand button, and I will give you the sound to make the question. So you can see the raise hand button here next to these buttons in case you have a question. Otherwise, meanwhile, maybe Ruben, can you explain a little bit more details on the question you respond from the chat? I think it would be good to have the general answer on one particular compound.
Yeah, sure. So I received one question regarding one of the flame retardants which was tested for bed linen applications. It was the tetrakis hydroxymethyl phosphine sulfate. And the question was related if it was safe, its use, because it's considered both mutagenic and reprotoxic. And the risk assessment we performed basically lead to the conclusion that the formulation which contained this compound was not in the safe conditions to be used as a replacement for bed linen applications, due to two main reasons. One, was the hazard characterization of this compound, which I forgot to explain, but to do the hazard characterization, we took into consideration the CLP classification and all the toxicological and ecotoxicological data we found in the literature. So due to the classification for CLP, the hazard was so high in comparison to the expected exposure and during the application in the industry, and therefore we cannot assure the safe conditions for this compound under occupational risk assessment conditions. Additionally, we perform a risk assessment for environmental point of view, and the risk characterization ratios for 4 of the 6 compartments were higher than 1. And even though we could refine the assessment, the results won't differ so much from the ones we obtained. And that's why we discard to this formulation for the as an alternative for the substitution under bed linen applications.
Okay, thanks. We have another question in the chat. I think Ine is the best to reply, or Maria. That is asking, how were the list of flame retardants in FLAREX chosen? Was there any effort to incorporate bio-based or sustainable flame retardants?
The question is how we came to the selection. Am I correct?
Yes, how we choose them, and if there was bio-based or sustainable aspects taken into account.
At this moment, not. Yeah, of course, sustainability, yes, but we visited quite some stakeholders also to see what was in their interest to be evaluated also. A general trend nowadays is that there's a shift from alternatives even to bio-based alternatives, but you have to keep in mind that we have to make the selection of the flame retardants about 3 years ago, when there were no bio-based alternatives on the market yet. So in the meantime, it changed. So if you would redo the selection, we could incorporate the bio-based ones, but at that time that was not possible. So, but it was mostly also interest coming from the industry, which they wanted to see evaluated. Also, that was an important trigger to select some of the flame retardants, and also the feasibility for the applications we had in mind.
Okay, thank you. We have a question from the audience. Michael, you can now make the question. Michael, you raised the hand.
Okay.
You can talk.
I just typed it in. I was a bit surprised seeing the results from your PWOR forest screening. The dendrimer was commented to be the best performing alternative on polyesters, which is a bit surprising since we benchmarked a lot of our repellents versus that kind of technology, and normally we see that the performance, especially after washing, is degrading and getting poor. So I was curious to know whether any durability tests were done, means whether the fabrics which were screened in that panel had been submitted for some industrial laundries or stuff like this, which would be the case, for example, in home or fashion applications.
Okay, Ruth, can you please go ahead with the question?
Yes, sure. Hello, Michael. So yes, in our case, it was the best results were obtained by the dendrimer, and we washed the samples. 10 washing cycles were done, and yeah, and the results that we showed in the presentation are the ones that we obtained. It was an knitted polyester fabric. I don't know which type of fabric did you use, but the product that we tried, it was just one product, performed really good with this substrate. Okay, and the washes you did that were 30, 40, or whatever temperature? 40 degrees, if I remember well. Okay. Okay, yeah. Thanks. Anyway, welcome. I guess we get on the presentations which were shared today.
Yes, we will share the presentations and also the recording of the event. in the coming days. So in the next 2 or 3 days, we will be sharing all the different presentations and the recording.
Perfect. Thanks a lot.
You're welcome. Thanks. Do we have some more questions? Well, in case you have some further questions that have not been answered or you didn't have time to make the question, you can send us an email and we will try to provide you with an answer. You have my email from the registration on the agenda, and you can find us on LIFE-FLAREX.eu. You will receive then tomorrow email with a survey about the event, and then we will be sharing the PowerPoints and the recording links by email in the next few days. So with that, I would like to thank you all for participating and for attending, and also all the speakers for their presentations. So with this, we will finalize the event now, and thank you a lot for your attention. Thanks.